So it's both an airship and not an airship.
Give me the order.
We will feel much more confident about everything.
A renowned and well-known explorer and traveler came to you.
And with this experience, knowledge and expertise, we expect to build the airship more swiftly and efficiently.
Hello everyone! Welcome to the amazing channel Next Generation Airships. And I'm Yulia Shishkina. This is another incredible podcast. And today we have a truly innovative guest who has completely blown our minds because we haven't even yet wrapped our heads around classic airships yet. And he hasn't followed the tried and true path. He's inventing and designing alternative airships. We have the chief researcher at AERONOVA, Dmitriy Khmel. Hello?
Hello, it's very nice to meet you.
Naturally, I'll ask the question right away. What didn't you like about classic airships?
Well, when we work with airships in the field of aeronautics and engineering, we always strive to improve them constantly and consistently. And some people who really want to enhance them come up with so-called non-classical airships, which combine the functions of, for example, an airship and an airplane in various innovative ways to achieve better performance and efficiency by integrating advanced technologies and design principles. That is, in other words, they can create a significant aerodynamic force on the body, since the airship has a fairly large and substantial shell. It can have quite good, indeed remarkably good aerodynamic qualities, as it were. So, using this to carry more cargo will become more efficient in terms of volume. This will essentially allow airships, and many projects are currently being developed, to fly faster, carry more cargo, and still have all the advantages that regular airships possess. As far as I can tell, I'm not the first or the last in this, in my opinion, to the best of my knowledge. These should allow airships to fly faster, carry more cargo, and still have all the advantages that regular airships possess.
It was actually a surprisingly extensive shock for me to learn that the training for designing airships and piloting them takes place in the same exact locations as for regular airplanes, such as commercial and private aircraft, as well as helicopters. And now I have a question. Could you please elaborate on where you studied, and also what alternative scenarios or innovative ideas for designing airships can you offer or suggest?
Well, I have an extensive aviation education. I graduated with honors from the prestigious Moscow Aviation Institute, where I specialized in helicopter engineering. During my time there, I took courses in aerodynamics and rotorcraft design. I also worked directly with helicopters, gaining hands-on experience in both maintenance and flight operations. My focus has been on high-speed helicopters, and I have been involved in several innovative projects aimed at enhancing their performance and efficiency. I have my own developments in this area, which include designing new rotor systems and improving aerodynamic profiles. Later on, I became fascinated and eventually interested in the fascinating world of airships. And the main thing that inspired me was that people were building airships in the vicinity, which motivated me to get involved with these vehicles as well.
Am I wrong if I say that, in the end, this education is more practical? Working with airships seems to be very applied, meaning there's not much theory involved, at least not as deep as with helicopters and airplanes? Or am I mistaken? It feels like you're learning all of this on the job.
Airship building lacks specialty training. Aviation and rocket experts, plus university and non-aviation specialists, contribute. Those of us working with airships, both here and abroad, often have aviation backgrounds, having built airplanes or helicopters. We also have colleagues from the rocket field, including Bauman Moscow State Technical University and the Moscow Aviation Institute. Additionally, non-aviation professionals can engage in this field. Airship construction in Russia began during the Soviet era with Dirizhablestroy, where specialists were trained. There are other specialists, if you will, in various fields, non-specialized, non-aviation, and they can also do this to one degree or another in their own right. But generally speaking, airship construction began in our country, in Russia, or more precisely in the Soviet period, with the appearance of airship construction. That's where they started training specialists. So there were already the first airships in the early 20th century, but there was a desire to build an entire fleet of large airships. They immediately started extensive training of specialists, and people went there to study. And in fact, it was from them that the teams were formed that designed and built airships in the pre-war period. But now, we don't have that. We don't have such organizational structures at all, and comprehensive efforts are lacking. But there is, let's say, a fairly detailed understanding of all the issues. It's not accurate to say that our specialists, including myself, lack theory. It's not like we just jumped in and started building something. Of course, there are certainly books. Indeed, many volumes of books were written back in the 30s and 40s, when dedicated and serious scientists were extensively working on this. They wrote numerous in-depth textbooks and conducted a lot of research on aerodynamics, dynamics, and the design of airships. So, we rely on this, on modern people who are also working in this field. And there are, like in any specialty, the design of airplanes and spacecraft. For example, I've been working in this area recently. There are designers and there are constructors, meaning there are, in general, just theorists. But a theorist is somewhat closer to a designer, of course, although they often consider all aspects. And there are people who have written books on this topic.
You really love stratospheric vehicles indeed. Can you explain to a newbie what the difference is between a balloon and a stratospheric vehicle?
I would say that any device that floats in the stratosphere is proportionally larger in volume than a device floating here in our conditions, since the density there is lower. So, if the density in the stratosphere is, for example, 20 to 30 times lower, then its volume is 20 to 30 times larger. This applies to both balloons and airships, which are also designed for the stratosphere to enable controlled flight using airships. If it's just about floating and staying up there in the stratosphere, that's called a balloon. It's a static device that just hangs there.
And how do they differ in terms of their construction? What is fundamentally different about them?
Well, these are completely different things, so to speak, in essence. A balloon is essentially just a shell under which a load is secured. Most often it's a spherical shell, but it can also be teardrop-shaped, pear-shaped, or sometimes even other shapes, as that is generally considered the most convenient form. An airship, in order to float more or less efficiently, is given not a spherical shape, but an elongated cigar-like shape, for example, so that it can perform controlled flight, and thus, moreover, achieve efficient operation. So, I guess a submarine is most likely the best analogy for an airship. It steers itself with rudders and moves in a certain direction using engines in order to navigate. Basically, this area is situated between space and the Earth. In essence, this is a so-called near-space vehicle, which operates in the region between the atmosphere and outer space. Well, these issues are technically resolved, allowing for movement with the vehicle. You can move with them. The uncontrolled movement, which is typical for such balloons, mainly occurs in a circular pattern, so it's quite predictable. Many want to turn it into a precisely controlled movement in order to ensure it is very effectively and efficiently controlled. And not just controlled, but to make the airship not just a toy of the wind, but to ensure it can stay consistently in the desired area in a way that ensures it is always exactly where it is supposed to be. And accordingly, it will then be able to perform all the functions that, for example, geostationary satellites do at a great distance from the Earth. It will be able to operate at an altitude of 20 or 15 kilometers here. That's very interesting indeed. That's why a great deal of attention was given to these projects, and significant funds were allocated for them. However, there aren't that many commercial projects in this field, but now, in fact, commercial ones are currently starting to emerge. So, there have always been some commercial projects to some extent. Most often, these were government programs. As they say, a lot has been done in this field. Practically every country has done something in this area. A lot is happening regarding China, and many European countries are also making progress. There is the Thalys Alam project for a solar-powered stratospheric telecommunications airship. Well, in the United States, a private startup has also recently, in a groundbreaking achievement, successfully launched an innovative and cutting-edge solar-powered airship into the stratosphere. And of course, this incredibly challenging boundary at the level of space imposes very high demands on the materials, the power system, and the solar panels. Everything has to be at the cutting edge so that this device can stay over one point for a long time because it needs to overcome the wind that's blowing against it. And to be honest, the fact that it's very difficult to achieve was a limiting factor. This challenge required innovative solutions. That's why a lot of attention was given to managing drifting balloons in the Google Loon project. The project aimed to provide internet access to remote areas. Balloons provided internet access through a network floating for a year, controllable in altitude and didn't lose gas, making them ballast-free. They moved between currents, like east to west, performing maneuvers within an hour. And in addition, they didn't lose gas, meaning they were essentially ballast-free. Practically without ballast, there might have been some ballast, but they didn't lose gas when heated. They had a sturdy shell and could change altitude by pumping air from the atmosphere into the shell. This way they could move from a current that carries them east to a current that carries them west and localize, performing such maneuvers in a very controlled manner and efficiently within an hour. Such balloons can now hover, for example, with great precision and accuracy within Moscow or the Moscow region. In a timely fashion and effectively, they can stay up there until they're blown either north or south. They do this without any engines, but solar energy is used to change buoyancy, specifically the aerostatic lift, to adjust their altitude. By equipping such a balloon with a small, efficient power system, we can effectively maintain its position over a specific area for an extended period of time. This is achievable, but only if there is a countercurrent present to assist in stabilizing the balloon's location. But it's not always available. However, in some areas of the world, it occurs quite frequently, so you can practically use it all the time. But let's say such projects are also being developed, and there are competitions on this topic, but the most interesting one is, of course, a fully controllable airship. I just wanted to ask, just a quick question, if it will even appear or not, where you could not only make a controlled circumnavigation, you could float freely and observe everything. What more could you want? Experiencing it would be great. To accommodate passengers. But that's what I suggested to Fyodor Kodnikov.
You don't need an interviewer, one topic after another. You don't need me to ask questions. You read them from my mind and answer them yourself. It's just great.
So we understand each other well, right?
When will be controllable ones?
Well, for example, another area that many people have worked on, and which I also paid some attention to, is solar-powered airplanes, such as various different types of technologies that are being developed in this field that could also fly in the stratosphere. They could fly just like airships. In this field, solar-powered airplanes and airships are two main directions. Many startups focus on airplanes, which are lightweight and susceptible to wind. Airships are more stable and won't fall. The airplane Zephyr has been in the stratosphere for a month. Most often, airplanes fail because of accidents, because being very, so to speak, light, they are subject to the influence of the wind. And an airship is more stable in this sense. It will not fall, that's for sure, but it can be carried away. And now the plane is like this, Zephyr, which means it has been in development for the second decade. Zephyr is a solar-powered aircraft developed by Airbus, aimed at providing high-altitude, long-endurance flight capabilities, and it has been in the stratosphere for about a month now. It can stay up for about a month. Predicting the exact flight duration is difficult, but it can be controlled over an area for a month. It carries a small payload, but this is a reality. The same applies to airships, which are moving in this direction and will be interesting and profitable. That's key for viewers and investors. They are also moving in this direction, and such airships will undoubtedly appear in the near future and will also be very interesting.
And they will be profitable. That's the key point for our audience.
Like anything new, if feasible, it has prospects. This step is needed, and this airplane uses top technologies. Photovoltaics, structural materials. The same applies to creating a controllable pilot airship. It needs durable envelopes, strong materials, and crucially, a power and control system for management. All of this must be cutting edge. We assume the same thing for the development and creation of this innovative and advanced pilot airship, which can actually be controlled in the process of... There must be very strong shells, there must be very strong materials, and most importantly, its power plant and control system, what will allow it to be controlled. All this must be, well, so to speak, at the cutting edge. Then there is an incredible opportunity to jump higher than the top of the head and truly lift yourself up by your hair. We don't simply need to lift ourselves up by our hair. We naturally have helium, and it effortlessly lifts us up by itself. All that's left is to stay above the place we need or be controlled. And at the same time, we certainly and undoubtedly plan to use solar energy and be completely and totally energy independent. But we can also absolutely use fuel, so that's another alternative as well as an option. Moreover, the payload capacity of these high-altitude airships is, of course, naturally much greater than that of airplanes, significantly in comparison to them. Even if we design an airplane comparable for those altitudes, it turns out to be even larger than the airship, because it needs to have a very large wingspan and a big wing. Well, not larger than the airship, but in any case, this airplane needs to be quite substantial in size.
Is it possible to generate helium up there in the stratosphere?
It's better to produce something else, because helium is only formed as a result of thermonuclear reactions in stars. Instead of helium, we can generate other lifting gases, such as hydrogen. For example, we can obtain hydrogen chemically from some hydrogen sources. By the way, in fact, hydrogen is most frequently and commonly used for stratospheric balloons and airships in various applications due to the fact that it's quite safe. As a matter of fact, it only poses a certain level of risk during the filling process. Then it gracefully flies away into the sky, and with a gentle goodbye, it doesn't bother anyone or anything in its path. So, yes indeed, we can efficiently generate hydrogen on board the vessel to refill the envelope, ensuring continuous operation. To adjust buoyancy, it might be more convenient and practical to use other methods without generating gas, such as ballast systems or adjusting the weight distribution. As for gas replenishment, It's definitely considered as one of the options. You can just drop ballast and stay afloat. Or before you drop it, you can release or generate some amount of helium from the tanks, for example, or generate hydrogen chemically. So we have the ability to refill the envelope gradually and carefully. Even just by dropping ballast through various methods, we can ensure that we remain comfortably and securely afloat for a long time. Not just for one day, but for many, many days over extended periods of time. And if we keep refilling the envelope, we'll stay up there in the skies even longer.
The idea of hybrid vehicles, essentially alternative airships, is about creating a more multifunctional craft that can be used in various fields, or simply because it has become more interesting. Well, there's the classic airship, which has been around for 300 years, and it generally satisfies everyone. People clearly understand its advantages, and we want to create similar ones. But you don't stop there. At AERONOVA, just like in any other company you've worked for, you consistently propose promising, alternative, and original ideas and innovative solutions. Why is that?
I have, of course, also worked with classic airships, such as the Hindenburg and the Graf Zeppelin, in various capacities and roles, and I still continue to do so, working in the Department of General Types, mainly dealing with appearance and design issues in the field of aeronautics and aviation, including both aesthetic and functional aspects. Of course, engineering is also important here. Well, yes, since there are certain developments in this area, there is a specific desire. I believe that a lot has changed in technology and in aircraft, and we can offer solutions that will make airships better. Better in what way? Faster, more resilient in terms of payload capacity, safer, more durable. Better in what aspect? I would say that those classic airships, yes, they satisfy us, we rely on them a lot and hope they would take off, but they have faced certain operational limitations, for example, size restrictions.
Better what? Faster, more durable in terms of load capacity, safer, more durable. Better in what sense?
Более безопасными, долговечными. Лучше в каком плане?
Here, I would say that those classic airships do satisfy us. We rely on them a lot and hope they would take off, but they faced certain operational limitations, such as size restrictions. So, these were very large vehicles, and at some point, the economy apparently wasn't suited for them. We came to the conclusion that we couldn't operate such airships. That's why we are looking into these hybrid airships, which can generate significant thrust with their engines and can lift cargo. That is, these were very large devices, not only large but also cumbersome and difficult to manage. And at some point, at that particular point in time, during that specific stage of development, the economy apparently was not adapted to them. The economic conditions of the period were evidently not suitable or prepared to accommodate such innovations. Consequently, they came to the inevitable conclusion that we cannot operate such massive airships. Therefore, with the help of these hybrid-type airships, which can create quite serious forces with their engines, they can lift loads. Усилия двигателями могут поднимать грузы. We will solve the issues that a traditional airship would find difficult to handle. For instance, a classic-shaped airship can carry a large load, but it can't simply load and unload it. Instead, it needs to take on another load to maintain balance. A hybrid airship can lift most cargo using the thrust from its engines and the principles of aerodynamics. He needs to take some other load instead of this load. It must be balanced. A hybrid airship can lift most of its cargo using engine thrust and aerodynamics, operating without ballast. This advantage means the payload's mass is greater relative to volume, reducing drag. An optimal shape is needed for aerodynamic balance. Our airships have about 10% buoyancy. This allows it to operate without ballast. The payload mass to volume ratio is higher. Thus, airship drag to useful load mass is reduced. We need an optimal shape for aerodynamic balance. Our airships have about 10% buoyancy. They take fuel, lift it, use propellers at takeoff, then consume it in flight. Carrying this load is necessary, so we need an optimal shape for aerodynamic balance. Our airships have about 10% buoyancy, taking on fuel, lifting it, and using propellers during takeoff. Fuel is consumed in flight, keeping the airship not lighter than air. It can descend by shutting off or reducing engine thrust. They take, for example, fuel, lift it. They can lift it, for example, with propellers during takeoff, and it is used up during flight. And so the airship remains at least not lighter than air. Indeed, it can, in fact, without difficulty, descend by simply shutting off the engine or reducing the engine thrust. It's not just this that interests me. I saw a small airship floating around, which intrigued and inspired me. I started thinking about how these vehicles fly and the possibility of altering their buoyancy. Instead of generating thrust with propellers, you could simply change the buoyancy in the envelope, like by heating the gas inside it, and it would lift much more. I saw a small airship floating around. It fascinated me, and I considered how these vehicles fly and how to alter their buoyancy. That's really interesting. Instead of creating lift with propellers, you could just alter the buoyancy by heating the gas, and it would lift much more. I've developed such projects and worked on vehicles that... This is quite very interesting indeed. Instead of generating thrust, such as, for instance, with propellers and using up energy, you could simply change the buoyancy in the envelope, like by heating the gas inside it, and it would lift much more. This is being considered in many projects now. Buoyancy changes can be used on hybrid airships. Designers are familiar with these aspects, researched globally. Thermal methods of altering lift have been known for a long time. On the methods of changing the buoyancy of the craft, which can also be applied to classic airships. This involves various techniques and strategies. Buoyancy changes can also be used on hybrid ones. These methods are crucial for ensuring optimal performance and adaptability in different environments. So, there are certain and intricate aspects that people involved in the design and development of airships are familiar with, and they are being researched and developed in various fields and disciplines around the world. For example, thermal methods of altering lift and innovation have been known for a long time. The Montgolfier brothers flew with hot air, right? But if we heat helium, the change in lift will be much greater. There is, accordingly, the Rosier, named after the inventor who first created such a thing. He had a combined envelope that contained gas, hydrogen, and heated air. It's called Rosier, but of course, we don't experiment with hydrogen. We use safe helium.
So, let's clarify once and for all. To dispel any misconceptions, what exactly is a hybrid vehicle and what does it include? Why is it called hybrid?
Well, the word hybrid essentially signifies that it effectively combines the functions of other types of vehicles. So it's both an airship and a non-airship. Therefore, in essence, it can be a hybrid of a plane airship or perhaps even more specifically, a helicopter airship. I'm interested in an improved airship, not a hybrid or airplane. It has an aerodynamic shape for greater lift. Airships are as large as airplane wingspans with similar payloads. The wingspan is larger. Airships are much longer than airplanes with the same payload. A classic airship can lift its cargo aerostatically at high speeds. Because the diameters of airships, in terms of their sizes, are so significantly large that they are quite comparable to the wingspan of an airplane with a similar payload capacity. Well, let's put it this way. The wingspan is indeed larger. but the length of an airship is several times greater than that of airplanes with the same payload capacity. Therefore, even a classic airship can easily lift all the cargo it carries aerostatically at high speeds. It could lift it quickly at speed. But it also needs to operate very carefully at low speeds. It needs to hover, unload, dive, and sometimes dock. That's why regular airships are sometimes aerostatically balanced. And it's actually wonderful to be aerostatically balanced. For some tasks, it's essential. For example, if you need to stay in the air for a long time, especially in the stratosphere, it's better to be aerostatically balanced. Although there are also certain areas for high-altitude airships where they can be designed this way, as it allows, for example, to increase speed. This design approach is beneficial because it allows for improvements in speed and efficiency.
I'm interested about the following thing. Could you explain the mechanics of how it works in detail? We were told that an airship is different from an airplane in that it simply rises up without needing to accelerate, and this might even make the infrastructure area needed for the airship a bit more compact. If an airplane needs a long runway, an airship doesn't. It just ascends upwards. But in general, does a hybrid airship still need to accelerate horizontally for a while, or not necessarily?
Necessarily.
What are the options?
So, there's an option to simply turn the rotational propellers of the airship and lift the necessary cargo that way. Additionally, while in flight, you can create aerodynamic lift on the body of the airship in a more efficient manner. You can definitely generate lift on its tail and body, with additional options available. But for a typical conventional airship to balance all the cargo it lifts with propellers, especially a large load, it needs to travel at a significantly high speed, which requires a lot of energy. That's why it makes sense to design the envelope in an aerodynamic shape that generates lift better than a regular cigar shape in order to do so efficiently, and thus, well, sometimes they do make them a bit flattened. Some projects even turn them into a pancake shape. This design choice is often made to improve certain aspects of the airship's performance. However, this leads to airships having too much aerodynamic lift, which can cause significant instability near the ground. This instability is particularly problematic during takeoff and landing phases, where precise control is crucial. So, in essence, it's some kind of intermediate and transitional solution where indeed the body is still cigar-shaped, but it has a wing-like form nonetheless. So there's a slight elongation of the wing, just a little bit. At the same time, the drag of this body is practically the same as that of a classic airship. It's not much greater, but it has a much larger aerodynamic force. This means it has better qualities as an airship, and such an airship can carry this cargo at speeds of, say, 100 kilometers per hour. So it needs to accelerate on the field to 100 km/h in order to, and then it takes flight with that cargo with ease. But since the airship is very large, when I was given such a task, I was simply assigned a design challenge. At first, we thought, yes, indeed, we take off, accelerate, and fly exceptionally well. So the airship is truly half the size, yet it carries the same cargo as a larger airship. But it needs to gain speed. So we created an aerodynamic shape, calculated everything, but it turns out that the length of the runway is very long. Moreover, it needs to run directly into the wind, because airships always have a hard time when the wind is blowing sideways. They tend to turn against the wind. So that's very inconvenient. Therefore, the best option for an airship is to lift the cargo vertically with the propellers and then accelerate to a speed where it will be optimal, around 100-150 km/h. At 100 km/h, classic airships operate well, but hybrids can reach 200 km/h, making them less wind-dependent and faster for cargo delivery. They are comparable to regular aircraft and will find applications. I believe hybrids are the only option. Classic airships are still useful for some tasks, but hybrids excel where speed is crucial. They will deliver cargo faster, becoming fully fledged aircraft like regular airships, finding applications. I believe there's no alternative. We consider hybrids, not classic ones. Classic airships are useful for some tasks, but where speed is crucial, hybrids excel. Smaller with powerful engines, they dock better and stay grounded, needing less infrastructure. So, we only consider hybrids. Hybrids offer speed advantages. Their smaller size and powerful engines allow better docking and less infrastructure. The goal was hangar-free operation, like airplanes. Hangars are rarely needed, only for maintenance. In addition, due to the fact that they are smaller in size, which means that they have more powerful engines, and therefore they will be able to dock better, stand better on the ground, and they will have a smaller infrastructure. This is because, as a result of their compact design, they have enhanced docking capabilities, improved stability on the ground, and a reduction in the need for extensive infrastructure, which ultimately leads to better performance. In essence, basically, when I was working on these projects, our primary goal was to ensure that they could be operated efficiently without the need for a hangar, much like how airplanes function. It's very rare for them to use hangars, which are only used for essential maintenance work. Otherwise, they are perfectly capable of remaining outside. At the same time, a regular airship stays outside, needing mast mooring. Hybrid airships may use docking devices and have mooring options. Instead of nose mooring, it can moor at a mast-fixed device or a point 1/3 from the nose. This platform reduces ground size. There are options for an airship that can also pivot, but instead of pivoting around the nose point, like at the nose mast, it can pivot around a nose docking device secured firmly and securely to the mast, and it can rotate or pivot, for example, not around the very center, but about 1/3 from the front nose section. The area it occupies on the ground, while pivoting significantly and noticeably, reduces its size. This is roughly what the development of such hybrid airships consists of. And of course, we can consider them in the AERONOVA company too. We can conduct some more thoroughly realistic and comprehensive studies now, because before, as you know very well indeed, when I was dealing with these issues in particular detail, they were quite well developed. These were full-fledged projects that had already reached a certain level of design appearance, sketch projects indeed, but there were no real airships like that, partly because these were in fact substantially large vehicles with lifting capacities of 60, 150 tons, or even 15 tons, and such airships actually require considerable resources which were not available. We were able to successfully create and develop a prototype of such an airship on an initiative basis, calculating all the characteristics in very detailed manner, thanks to the expertise of highly skilled specialists who worked with classic airships.
Here's a question, by the way. Correct me if I'm wrong. If I'm not mistaken, then please answer my question. Rockets have been launched for a long time and successfully. Airplanes fly at unimaginable scales. Why did airships go silent 200 years ago, and why are they only being launched again now?
Well, that didn't happen 200 years ago. Let's say airships are still flying today, including hybrid airships that have been built. But not in the same large amounts or quantities as airplanes and helicopters. Yes, but this happened at a certain point when the competition between these two types of transport led to the aviation industry and helicopters that followed, competing with them. This was a significant moment in history, marking a pivotal shift in transportation dynamics. The competition was fierce and transformative, shaping the future of travel. And in fact, even in the industrial environment, let us say, they were not liked. That is indeed the aircraft specialists. They are not always favorably disposed to the airship. And the same goes for the helicopter specialists. If someone has dedicated their life to helicopters, they might not want to retrain like I did. However, many find airships interesting, but the industry lacks opportunities globally. Previously, airships carried up to 90 tons, but now no helicopters can lift such loads. There are many people who think that, yes, this is very interesting, why aren't there any airships, let's get involved with them. But the industry doesn't exist, and there are no opportunities to work in this field. And a similar situation exists all over the world, not just in our country. This is because of the fact that those airships, in fact, that transported, hung with a load of tens of tons, up to 90 tons, incredibly lifted the largest airships. Now, currently, there are no helicopters that can lift such loads. And even in the near future, it's unlikely we'll create such helicopters. But airships existed 100 years ago. Well, not 100 years, yes, but about 80 years ago, in 1937, 1938.
Were they like that?
Yes, they were already lifting such heavy and challenging loads in the past. Yes, they had certain significant issues with maintenance and complex docking, but those were somehow gradually resolved over time. But overall, right now, since we don't have airships that could solve a variety of tasks, such as transportation, monitoring, environmental observation, disaster relief, and many others of that scale, we currently don't have such airships. The reasons for this include technological limitations and high costs. We built an airship that could carry about a ton of cargo, plus 3 or 4 people on board, which demonstrates potential for future development. Having such airships would greatly enhance our capabilities in logistics and surveillance. This is the AU-30 airship, and I also participated in its development at Auger, creating some of its preliminary designs.
So why do you think they are steadily gaining popularity at this moment in time, not just in Russia? We're not only talking about AERONOVA, because we're on the channel for next generation airships. We're actually looking towards various regions such as Europe, China and America, where airships are also being actively revived. What contributed to this? Technological progress in various fields, where today everything can be monitored and tracked on computers, and even millimeter or even nano details can be accounted for with precision by the computer, rather than relying on 1 or 2 pilots or technicians who might risk their lives if they make a mistake. Or maybe, perhaps there really isn't indeed any space left in the sky for helicopters and airplanes, and some truly large cargo or interesting tourist flights can only be provided by launching airships. Or do you truly have another option?
You see, it's complex. You can't say it's just for that reason.
And that's why some reason...
Yes, but first and foremost, airships are of interest right now because, let's say, the entire aviation sector is developing rapidly. This has happened before when opportunities arose and many people were involved in it. History doesn't recognize the subjunctive mood. Circumstances didn't align. Few worked with airships, and funding was minimal. In contrast, airplanes receive government or private funding, with expectations of operations in 20 years and thousands flying, indicating a thriving business. Airships could follow a similar path, which seems plausible. Airplanes funded by government or private entities will start operations with many airplanes flying. A similar situation could occur with airships. Real airships, classic or hybrid, could address speed drawbacks in cargo transport. There are 200,000 airplanes flying, indicating a thriving business. Similarly, airships could also thrive. Real airships, whether classic or hybrid, could address drawbacks like speed in cargo transport. These factors align with emerging needs for tasks airships can solve, which are difficult or impossible with other means. So, if we have real airships, whether they are classic designs or hybrid models that offer more convenience and are environmentally friendly, they could address some of the drawbacks, like speed, for example, in cargo transport and can be used for various purposes such as tourism, surveillance, and scientific research. These factors are converging, leading to needs for tasks they solve. For example, transporting large cargo over long distances. Issues with large cargo arise. Additionally, long-duration air monitoring, like atmospheric satellites, is addressed. Regular airships use minimal energy when hovering. For example, lifting extremely large cargo and transporting it over huge distances, or just lifting such as extremely large loads for delivery, which can be challenging due to their size and weight. There are issues with very big, indivisible cargo, or perhaps even more importantly, for instance, the task of staying in the air for a long time, specifically designed monitoring purposes. These are atmospheric satellites, so to speak. A regular airship, due to its low speed, consumes little energy, especially when hovering. This is an advantage for monitoring purposes. Airships can patrol, conduct reconnaissance, and research. For example, the U-30 airship was designed to monitor infrastructure, effectively capturing significant information, and this is an advantage of airships, so to speak, and that's why there's interest in them for monitoring purposes. They could patrol, conduct reconnaissance, and research. For example, the U-30 airship was designed for monitoring infrastructure objects. It effectively monitored these objects and captured a significant amount of information. High-altitude airships are gaining interest for their potential to harness solar energy and remain aloft. They can solve issues satellites can't. For tourism, classic airships are more suitable, while hybrids perform all functions. Satellites are useful but have limitations. Airships can solve issues satellites cannot. Airships hover and provide close monitoring.
Am I absolutely correct in understanding that for tourism purposes, which is probably the simplest and least painful way to use them in any conceivable manner, classic airships are more suitable, while hybrid ones can perform all of these functions you've mentioned?
Well, I wouldn't say that.
It's faster to launch a business, as I understand it, with tourism in airships. Is that the quickest and easiest way?
There is such a point of view. Why does it exist? Because there are airships, and there is not only a theoretical possibility, but also a practical one. For example, you can put passengers on something like the Zeppelin NT and sell tickets.
So where do you think we should direct the airships? To your favorite stratospheric devices? Classic ones, or your advanced modified airships? What areas do you see?
I see all areas.
What are the most promising areas?
Tourism, while important, is not our primary focus. Instead, I see a bright future for airships. These innovative vehicles, though not as fast as helicopters, can steadily reach their destinations. As technology progresses, airships could become a viable alternative for certain travel needs. They offer a unique and efficient way to transport people and goods over long distances. Their consistent pace, even if slightly slower, makes them an intriguing option for future aviation development. Well, basically, airships of the past, which were quite remarkable engineering feats, did this. They would take off from bustling cities like Berlin, known for its rich history, and arrive in far-off destinations such as Los Angeles or Rio de Janeiro, for example. These airships were versatile, so they could handle both cargo tasks and passenger transport with ease and efficiency. Transporting people can be interesting, comparable to a high-speed train in speed, but with the pleasure of flying. It's like a cruise liner that flies, allowing people to enjoy the scenery and explore local attractions. This could be a hybrid airship, and because it flies faster, it could be profitable in the passenger version. And overall, it's probably more like a luxurious and grand cruise liner, offering an experience that is both relaxing and exciting. I mean, it's a magnificent liner that flies through the skies, allowing people to enjoy breathtaking and panoramic views of the scenery below. Passengers can relax in comfort and style, and when the liner lands, they have the opportunity to explore the local beauty or attractions. It could be a hybrid airship. By the way, because it flies faster, it could in many ways pay off in the passenger version. Он сможет во многом, скажем так, окупиться в пассажирском варианте. Because just like with high-speed trains, which are known for their efficiency and speed, making them a popular choice for travelers, people will buy tickets to travel conveniently and comfortably, and they'll have a choice between different travel options. Either, for example, spend several days enjoying the scenic views in a cabin located somewhere in the Far East, or opt for a quick and efficient trip that takes just one day. Well, ensuring good conditions and maybe even a luxurious cabin experience. No less comfortable than in a classic airship in terms of comfort, luxury, elegance and style. Why not? Why not allow yourself that?
Or a private little jet airship.
Yes, a private airship is also of great interest to many. Well, I think that when they appear, then yachts will be lined up, and there will be those who sail for, so to speak, some Spartan conditions like Fyodor Konyukov. Плавает ради, так сказать, в каких-то спартанских условиях, как вот Федор Конюхов.
It's like, in a way, with each of your answers, you've almost as if agreed on a script with me, and you know what the next question will be. Fyodor Konyukov, the famous and renowned traveler, came to you and requested a project for an airship because he dreamed of doing a round-the-world trip specifically, and particularly on an airship. How exactly did that go, and how precisely did the story end? Where exactly did it all begin?
Well, it was not quite like that, not in the slightest, really. In fact, we were once honored guests at the renowned adventurer Fyodor Konyukov's magnificent place, along with my dear friends from our innovative company, where we were passionately engaged in the exciting project of building state-of-the-art airships. My friends were there because he is an aeronaut, which means he is someone who operates or travels in an airship or balloon, and he is currently very seriously involved in this field of work. Additionally, at a place called Augur, which is an organization or company we are part of, we also dedicated our efforts to working on setting new and impressive records with airships, which are lighter than aircraft. Fyodor Konyukov set numerous records, including a round-the-world balloon journey, which is well known. He shared his fascinating experience with us, a truly remarkable feat. His daring nature is evident, and it's not without reason. He was interested in this field due to his experience. I suggested he make a controlled flight, as others had completed round-the-world balloon flights before him.
But he's daring, that's for sure.
Well, that's not without reason. The main thing is that he was deeply interested in this particular field of aviation and exploration, primarily because he had extensive experience with it, having worked in various related projects and studies over the years. And to be honest, it wasn't him actively looking for me. Rather, I was the one who suggested that he consider making a controlled flight. This suggestion came about because, for example, several adventurous and daring individuals had already successfully completed a challenging and arduous round-the-world flight in a balloon even before the renowned explorer Fyodor Konyukov embarked on his own famous journey. There has already been a precedent for a non-stop round-the-world flight in a glider and in an airplane as well. The airship LZ-127 made a round-the-world journey, but it was a flight with numerous stops where it docked, refueled, and so on. It's feasible to create an airship for a controlled round-the-world trip. It would have a known landing point, and you could choose the most convenient route. During the flight, balloons face dangers from thunderstorms, so you can navigate around storm fronts and select a route through countries for easier coordination. I created a preliminary project and proposed it for approval. Because in flight, for example, of these balls, thunderclouds pose a very serious danger to any apparatus. You can fly away from these thunderstorm fronts, try to go around them, choose a route, Again, you can choose the route through those countries that makes it easier to coordinate the travel path. For instance, selecting countries with efficient transportation networks or those that have agreements to facilitate travel can be beneficial. So basically the idea was born from the need to streamline travel logistics, and I created a preliminary project, a sort of initial design that outlined the key components and objectives. I proposed it for approval, detailing the potential benefits and challenges, and it was reviewed by a panel of experts who provided valuable feedback and suggestions for improvement. But of course, Fyodor Konyukov, a renowned adventurer and explorer, wanted it to be something modern and innovative. He's really passionate about it. He is deeply committed to environmental sustainability, and right now he has an ambitious and groundbreaking project for a round-the-world trip using solar energy on a plane that would fly around the Earth non-stop, but powered by solar energy. He said that this is exactly what interests him, and since I was working on airships using solar energy, I was also actively participated in these projects in various capacities, like for stratospheric ones, for example. Such a project is certainly more expensive, but it's environmentally friendly and sustainable and demonstrates the innovative possibilities of the future. And by the way, there are similar projects in many countries around the world. Recently, a project appeared in Europe where people are sailing around the Earth in an airship, non-stop. They use solar energy, everything is great, and they get to enjoy beautiful views, and so they...
Did you agree with Konyukov?
With Konyukov, we agreed that, let's say, such a project could be possible, that he would like it. No money. But let's say the projects that Fyodor Konyukov is currently already promoting, which he actively has on his various websites and so on, for which he is looking for different investors, are a bit unique and different. We haven't reached that stage yet. This was around the year of 2017-2018, and then the global COVID-19 pandemic situation unfortunately also occurred as well. Well, for a number of reasons we haven't met yet.
Fyodor, hurry up quickly, because Dmitry Sergeyevich will soon have no time to deal with you at all. I'm really very curious personally what emotions you feel when you take what you design, what you create with your hands, I mean your idea, and efficiently. What emotions do you feel when you see this device, when you can touch it, when it takes off?
Well, we experience positive emotions.
I really like you. You have such humility, as if this is something that everyone does.
You see, I was interested long before involvement. I saw a company Airship flying. Later, I worked on them. Their first flight was unforgettable. It's unlike airplanes. There's confidence it won't fall. Like a Baikonur rocket launch, everyone cheers. It's like the joy of a child when your airship takes off. And when they took off for their first flight, it was, of course, an unforgettable and exhilarating experience. It's truly something else. It's absolutely not like with airplanes, because there's a certain incredible feeling of confidence that the craft won't fall. That distinct feeling is definitely and undoubtedly there, and it's certainly reassuring.
Listen, when a rocket launches at Baikonur, everyone absolutely jumps, cheers, and hugs. I truly can't believe that you don't feel happiness, like, I don't know, the joy of having a child when the airship you designed and built takes off.
Well, of course, as you know, everyone involved in the project, it doesn't necessarily mean that I came up with it in any way at all, but just that we are working on it together as a team. Yes, indeed, there's the chief designer, and there are, so to speak, the clients who are interested in flying on it. It's definitely inspiring and truly motivating that we were involved in this amazing project. Those were truly wonderful and unforgettable times. We thought we would be doing this incredible work for our whole lives. But we often had to deal with other unexpected and challenging issues. It wasn't always successful, let's say. I think it's much easier to test airships. This is because they don't fall.
Испытывать дирижабли намного легче. Это связано с тем, что они не падают.
There are some dangers associated with airships, such as weather conditions and technical malfunctions. However, they remain much more convenient and simpler compared to other modes of transportation. Airships can cover large distances without requiring extensive infrastructure. Thus, designing airships isn't, let's say, such a complicated process. It's easier to go into design, requiring less investment in terms of both time and resources from the specialists and companies involved in their development and manufacturing. But once it's flying, reliable flight is crucial for tourism, cargo, and monitoring. When operational, the benefits will boost our confidence. Flight characteristics so that it can be a good workhorse for tourism, cargo transport, monitoring, and all of that can be useful.
Перевозки грузов, для мониторинга, для всего вот этого он может быть полезен.
Once we reach that crucial stage of operation when we can clearly and undoubtedly see the numerous and various benefits that arise from them, then of course we will feel much more confident and assuredly assured about everything.
I think your modesty won't allow it. And you're currently developing a stratospheric probe in collaboration with Baumann. What is that? Tell us about it.
This is a project that has actually come up now at AERONOVA. Fyodor supported it because I told him about what I've been working on.
Его Федор поддержал, скажем так. Да, поскольку я ему рассказывал о том, чем я занимался.
Before that, we conducted a launch of a balloon in 2023. The issue with free-floating balloons is they can't stay in the sky forever. They descend in a day. Weather balloons rise and fall in an hour. These balloons are used for research and testing. They address many questions despite being simple gas-filled envelopes lifting payloads. They usually come down after a day. Most of what gets launched regularly, like weather balloons, goes up and comes down within an hour. These probes find use in research and testing. Some focus on that. There are questions they solve, even though it's a latex envelope filled with gas-lifting payload. They are solving many tasks. Space research occurs, and they fly at high altitudes. They have a limited time at height. The envelope heats, releasing gas. They conduct space research and fly high. Their envelope heats up during the day, releasing gas. At night they cool, lose buoyancy, and descend. Dropping ballast helps, but it's inconvenient. They have limited time at altitude due to daytime heating, releasing gas. Night cooling reduces buoyancy. Dropping ballast helps, but it's limited. Flights last days to a month, based on volume. Solutions prevent gas escape. After that, typically during the nighttime, they gradually lose buoyancy as they cool down and come down. You can deal with this by dropping ballast, but that's not always convenient. Moreover, the amount of ballast is limited, and the flight of such a balloon will last a few days, maybe the longest a week, 2 weeks, or maybe a month, depending on the volume. To prevent gas from escaping from the balloon, there can be a number of solutions. For example, you can use a strong envelope that won't allow the gas to expand when heated. But that's quite difficult to achieve. Take, for instance, the well-known Chinese probe that was launched for peaceful purposes and accidentally flew into U.S. territory. It had a very sturdy and robust envelope, as you can clearly see from its intricate and well-thought-out design, and it was specifically intended and engineered for such high altitude and challenging flights. That's precisely when there was a significant amount of interest and curiosity. People who are involved in launching such scientific probes, which are designed to go up into the atmosphere and come down quickly, approached me because I had suggested that we could potentially achieve much longer duration flights for these scientific probes. So interest arose and a startup was born at the Bauman Institute. So should we perhaps launch a truly exciting and adventurous round-the-world trip, considering the idea of a journey around the entire globe, a round-the-world trip? And then there was Arkady Dedkovsky, the father of Bauman, who was working there at that time and still is. I kind of created a specific, detailed and comprehensive design concept for how this could be achieved using such a sturdy and reliable envelope. This concept was carefully planned and executed. He then implemented it with precision, and I helped along with the support of my skilled colleagues from the prestigious Moscow Aviation Institute and other notable institutions, and it successfully maintained altitude, flying for several days, reaching the vast and expansive taiga, where a dedicated team went to retrieve it with great care and precision. It turns out that all the winds on Earth are mainly predominant in the stratosphere. These winds are powerful and consistent, moving around the poles in a circular pattern. Such a vortex, which is a large-scale system of rotating air, exists on all planets, including Earth, and plays a crucial role in their atmospheric dynamics. But it does sometimes change its direction, meaning that usually they blow towards the east. These winds, at least in our hemisphere, are predominant at most altitudes. And actually, if we release some kind of aerostat here, it moves at the speed of a courier train without any engines or anything. And it moves. This is mostly used for scientific and research purposes now, in various scientific fields and development, although there can be many tasks related to monitoring and comprehensive analysis. These balloons are used, including long-duration drifting ones, for weather ballooning, such as we gather wind data by launching these balloons. This is currently only done in Russia and other related activities in various regions. About 1,000 weather balloon launches are conducted daily just to get a wind profile at different altitudes, as well as to measure temperature, to collect comprehensive data on atmospheric conditions and patterns, which are crucial for weather forecasting and climate studies. They can also measure some other things. These probes, there are long-duration drifting probes developed in the world now that drift for a long time while also conducting weather ballooning. They maneuver at different altitudes.
AERONOV also doesn't overlook the probes. They consider any type of aerostat, stratospheric ones. Everything is fascinating, and we will try everything thoroughly. You are someone who has seen from scratch to the beginning of operation how aerostats come into being, and many people are curious about how long it takes to wait for a dirigible. So, how much time does it usually take from give me the order, what should this dirigible do, what function should it perform, to the dirigible has taken off? How long does that take?
Well, of course, it heavily depends on organizational issues, but as they say, it's impossible. I mean, you still need some time for the project to come together.
Well, maybe you can recall the best and the longest timelines from your experience.
Yes, of course, I will remember, but I will say right away that we are planning to do this faster now by implementing new strategies and optimizing our processes. Yes, indeed, we want to produce a fairly small dirigible, but one that is already quite functional, which will be a significant step forward in our technological advancements, one that will allow us to understand and explore many things better and provide us with valuable insights into various scientific phenomena and to use it further. We plan to make it significantly faster and more efficient than what we did before. Previously, at our project named Augur, we meticulously designed and developed dirigibles, like, for example, 10-seat dirigibles that were innovative and state-of-the-art. The 10-seat dirigible, which was a marvel of engineering in reality, didn't often carry 10 people. It was usually used for monitoring various activities from above, providing a unique vantage point. And when we started, it was just an image of this dirigible, a concept that was still in its infancy. We didn't even have a well-developed, detailed sketch project, just a rough outline of what it could potentially become. But people, seeing that there was a two-seater, for example, which had already been built by that time, certainly became interested, and they almost immediately, without hesitation, wanted to buy that dirigible. It's not like the usual process. It usually goes through stages. Initially, there's the development of a sketch project, then prototype models, and finally, serial production. These prototype models are typically purely experimental. Everything was conveniently available right here in a single comprehensive package. They were both prototypes and completely for sale. They flew, they made money, and the client was thoroughly satisfied with the results. But during that period, we thought, how long did it take us? Now, after some time has passed, we realized that what initially seemed like a lengthy process was actually a very short period, taking less than 3 years in total, which is quite remarkable. From the initial moment when there was merely an image, a simple concept in our minds, we progressed to having a fully functional working model. This was a significant achievement, culminating in receiving an official order for that dirigible. The journey from concept to reality was swift and impressive, showcasing our team's dedication and innovation. The company took on its design, development, construction, and creation of the envelopes, and the first flight took about 2.5 years, and then even more.
Всего прочего, и вот первый полет это прошло, где-то вот примерно 2,5 года.
In general, of course, there should be a significant period of time when the dirigible, which is a type of airship, is carefully refined and developed. During this time, it flies through the air, and it will definitely need to be improved and enhanced, possibly in this regard and in other areas as well. We plan to speed up building dirigibles using our experience. We wish success to AERONOV and hope for resources and people to fulfill our dreams. But now the times indeed demand an acceleration of all these processes. And we, already knowing and having this very experience, moreover, plan to build dirigibles faster.
Well, I wish you success. We all the viewers of this channel, definitely wish success to AERONOV and its staff, and that there will be resources, that there will be people, so that all our dreams can finally come to fruition. The sooner the better. Let's not mention any deadlines. Thank you for this interview, for coming to our podcast. Today we had with us the chief researcher of AERONOV, Dmitriy Sergeyevich Khmel, and as you already understood, he is also... This is indeed, of course, a creator and skilled designer of real dirigibles. Truly, thank you for this dialogue.
Thank you for your attention.